Okay, so now we are going to discuss the second case for the estimation of one mean, which is when the population standard deviation sigma is unknown and you have a sample size which is less than 30. Okay, so for this case, you have to take note that both of these conditions must be satisfied. Okay? The standard deviation of the population must be unknown and you have a small sample size. So for the second case, the 1 minus alpha 100% confidence interval for mu is given by the following formula. X bar minus T alpha over 2 times S over square root of n and X bar plus T alpha over 2 times S over square root of n. And you will notice here that it is quite similar to the formula for case 1, except that since sigma is unknown, we already replace it with S in this formula. And instead of the Z distribution, we are going to use the T distribution. So we are not yet able to assume that the distribution to be used is normal. So what we use instead is the T distribution, which we will show in a few moments. Okay? But you will see that the form of the equation is quite similar. So you will have the point estimate X bar and you just add or subtract a margin of error. So the T value here is defined as the value in the T distribution with an area of alpha over 2 to the right, having n minus 1 degrees of freedom. So if you refer to the T table, which has already been uploaded in the file section of your Canvas page, you will have a T table that looks like this. So on the columns, you will just have to identify alpha over 2. And on the rows, you just need to identify the degrees of freedom, which is just the sample size minus 1. So in order to illustrate the use of the T table, we start with this example. So we have a random sample of 16 mid-sized cars tested for fuel consumption, having a mean of 26.4 miles per gallon and a standard deviation of 2.3 miles per gallon. Using this information from the 16 mid-sized cars, we want to find the 99% confidence interval for the population mean. So we want to find what is the fuel consumption of all mid-sized cars, okay, based on the information from these 16 mid-sized cars. So the given information for us, first n is 16, our sample size, which is less than 30. We are also given X bar, which is 26.4, and S, which is 2.3. You will have to read the problem carefully to identify that both 26.4 and 2.3 come from the random sample of 16 cars. Okay, so since this comes from the sample, we make use of the notations X bar and S. Okay, so since sigma is not known, okay, and you have a sample size which is less than 30, then we're going to use case 2. So under case 2, we're going to look for T of alpha over 2. Okay. Since we are looking for a 99% confidence interval, our alpha would be 0.01 divided by 2, which would be T of 0.005, where the degrees of freedom is the sample size minus 1, which is 15. Okay. So going back to our previous table, which I will show briefly, we just need to find 0.005 on the column and 15 on the rows, okay, which will give you the value 2.947. Okay. So again, you can verify using your T tables. Look for 0.005 in the columns and 15 on the rows. And you should get a value of 2.947. So this is now all the required values. So we just need to plug into our formula. Okay. So X bar is 26.4 minus the T value, which is 2.947 times 2.3, the standard deviation, divided by the square root of the sample size. And the same thing on the upper limit, except that it is added to the population mean or to the sample mean. And solving for both limits, you should get an answer of 24.7055 and 28.0945. Okay? So again, to put this into perspective, you have a sample of 16 mid-sized cars, which has a mean of 26.4. So the best point estimate for the fuel consumption of all mid-sized cars is 26.4 miles per gallon. But if we want a 99% confidence interval, then we extend the point estimate by adding our margin of error and subtracting, and we will arrive at this confidence interval 24.7 up to 28.1. Okay, so we are 99% confident that this interval will be able to capture the fuel consumption of all mid-sized cars.